Hello! In this video, we're going to prove the following theorem. The following are true. There does not exist an x such that p of x, if and only if, for all x, not p of x. And second, it is not the case that for all x p of x, if and only if, there is an x such that not p of x. Right, so we're going to prove 1 first. So let's start. Really, we're trying to prove if this is true, then this is true. And if this is true, then this is true. Let's start by proving if this is true, then this is true. And to do that, assume this is true. Our goal now is to prove that this must be true. And we're trying to prove a statement about all objects. So give me an arbitrary object. I'll call it x. And from here, we want to prove that x satisfies not p of x. Okay, well, assume for a contradiction, x instead satisfies p of x. Well then, we see that there is in fact at least one object that satisfies statement p, namely x. So there exists an x such that p of x. But wait a minute, this contradicts that we are working under the condition that there does not exist an x such that p of x. So our assumption that p of x is true led us to a contradiction. So we must instead have not p of x. So putting this together, we started with an arbitrary object x, and we proved from there that not p of x has to be true. Since x can be any object, this means for all objects x, we have not p of x. And so at this point, we have proven if this is true, then this is true. Now we're going to prove if this is true, then this is true. And to do that, assume this is true. Our goal now is to prove that this must then be true. But assume for a contradiction that this is not true. That is, assume for a contradiction that there is an x such that p of x. Then there is at least one object that satisfies statement p. And let's call that object c. But remember, this statement works for any object, so it must work for c. Therefore, this statement tells us that not p of c is true. So we have that p of c is true and not p of c is true. So this gives us a contradiction. Our assumption that there is an x such that p of x led us to a contradiction, so we must instead have there does not exist an x such that p of x. And so now, putting this all together, we have proven if this is true, then this is true, right? That's what we did in part 1. And we proved if this is true, then this is true. That's what we did in part 2. And so overall, this is true if and only if this is true. So this completes the proof of 1. Now we're going to prove 2. But I'm sorry about this in advance, but I'm actually going to leave out a lot of the details for the proof of 2. Because it's pretty much the same thing as 1, right? A similar argument as 1 can be used to show that this is false, if and only if this is false. Right, so I'll let you guys figure out the details for why this is true, but really it's the same thing as above, pretty much. But really, to say that this is false if and only if this is false is equivalent to saying this is true if and only if this is true, right? It's just two contrapositives. So we can conclude that this is true if and only if this is true. And so this completes the proof, right? And so yeah, that's pretty much the idea of how you could prove this theorem. And yeah, that's pretty much it for this video.